All right, my friends, welcome back to another episode of the Build Show webinar. That's right, we're doing something a little different. You're used to seeing us on videos. We've done a lot of podcasts, but we do these webinars on a monthly basis. And this is a live event, so if you're watching this later, you won't have Q&A. If you're here live, though, I want to mention that there's a Q&A tab on the top of your Zoom screen. So if you're using your phone like I am right here, there's a Q&A tab. That's where you can answer that's where we're going to look at the questions that you've got for us. And Ian and I are going to answer those at the end. So first off, I didn't even introduce you. Sorry, Ian.
Yeah.
Ian Schulman, he is the technical manager at hydrosolar.ca. And that's who sponsored today's webinar. We're going to be talking about basically solar heat and how to transfer that into something usable for our houses, right? Did I explain that well?
Yeah, so today I guess the generalized topic is going to be concerning solar thermal combination systems, seeing what's going to be the best option for the client depending on the market and depending on the climate that they're in.
Yep. And by the way, Ian's company, their website is hydrosolar.ca. They're selling throughout North America. They're a very education-focused company, and if you look at their website, this is more than just some collector tubes and a tank, although you can do a more what I would call simplified system and do that. We've got a lot of things to talk about today, with integration to HVAC systems, to using the heat that could be collected for heating and cooling, and believe it or not, cooling your house. There's all kinds of things we're going to jump into. But Ian, if you would, give us, with this demo that we've got kind of set up in the studio, give us the rundown. What do we got here?
Yeah, so what we have behind me is going to be a 30-tube vacuum collector.
Okay.
Its primary use is going to be to generate hot water. So we're using the hot water for space heating, domestic hot water, pool heating applications, potentially snow melt, or industrial like process heating. Right next to me, there's also a buffer tank. So the buffer tank is, think about it as a universal component to any of our systems or any system really on the market. It's a way of storing thermal energy, and it's a way to transfer the thermal energy from one media to another media.
Gotcha.
So in our tank, we have coils. We use the solar thermal with the coils, and then we use the actual volume of the tank for domestic hot water or for space heating.
Okay, so you guys are based in Canada, but these really could be used anywhere in North America. But in Canada in particular, it's cold a fair amount of the year. And so your system's interesting in that these tubes behind me that are the collectors, these are actually vacuum tubes. And there's like a blackish, dark blue coating on those tubes. And basically that's collecting the sun's energy, right? And then the gutter at the top, I'm going to call it a gutter, you guys probably have a better term for it, is actually where there's glycol coming through there. And it may be a little hard for you guys to see, but on both ends of that gutter, it looks like there's a 3/4 copper connection, 3/4 tube basically. So my assumption would be there'd be glycol running through this system, and that glycol would then be heated as it goes to your collector, which could be roof, could be ground mounted, could be a lot of different places. So that hot glycol is coming down here to this tank, and the water that's in this tank, this could be a domestic hot water tank. This also could be used for radiant heating inside the house too, right? Or it could go into a snow melt system if you're let's say looking for some free way to melt the ice and snow off your driveway. This tank then, the water and the glycol are not touching, they're just transferring the heat together. Did I get that right?
Exactly. So one of the main benefits of using the tank is going to be for thermal storage, so energy storage, like a battery.
Okay.
When it's nighttime, we probably want to use some of that hot water as well that we generate throughout the day.
Yep.
And this battery, depending on the size of the battery we get, gives us enough of a capacity to do that. If you just run your tank or your solar collector directly without a tank, you have to use your energy instantaneously. So in some applications, process heating, industrial, maybe you can get away with it, but in a conventional home, during noon, 2 p.m., let's say in the afternoon, nobody's taking hot showers, right?
Right.
So you want to conserve some of that energy to be able to use it at night, essentially with a tank like this.
Yeah, that makes sense. And I think you mentioned to me before we started, this actual array that's behind us would collect about 12,000 BTUs. Is that per hour? Is that right? Is that the correct rating? So this is basically 1 ton of free heat, so to speak. And so let's say you have 4 or 5 collectors, that could be up to 5 tons of heat you could be collecting outside and bringing that into something useful. As a side note, I vividly remember the first time in the summer as a kid, I tried to drink out of a garden hose, and my friend turned on the water spigot, and I grabbed the end of the hose and immediately spit out the hot water, right? We all get the principle here. It's really straightforward. And when we travel to hot climates, like tropical climates, I've been to Cancun with my wife several times. You see these big black tanks on the roof. This is kind of a version of what we're talking about here, right?
Yeah, exactly. So this is a version that's more adapted for North American climate, primarily where freeze protection is going to be important, and that's why it's split so the tank is inside of the house instead of being on top of the roof. And there's a glycol line between the two, preventing freezing from happening.
Yeah.
That's a primary benefit of going with a system like this. And the generalized idea of it is not just to generate this hot water and kind of use it right now, but it's to be able to store it. It's to be able to also, for instance, convert it from glycol to water or glycol to a different concentration of glycol, like a snow melt system or something else. Instead of filling a whole system with the same fluid, you can actually do a heat exchange in one of our tanks.
Gotcha. And Ian, one of the things I really like about your website, you guys are both sort of manufacturer distributor at the same time.
Yep.
You've got pricing on the website, so everything we're going to talk about today, you can click on the website and see it, whether it's Canadian or American dollars, and click right on it. And so, for instance, this kind of setup you're seeing here behind us in a simplified version, give us a range of cost for something like that.
So cost for solar thermal is going to vary about 5,000 to 12,000 Canadian US, depending on what configuration, what you're looking to actually get out of a system, is going to be the base starting price. But if you have an already existing glycol system, or like a hydronic heat, radiant heat, for instance, the cost can actually go down because you're now using heat exchangers instead of using a hot tank, for instance, and the cost difference is there.
Yeah, and I was on your website earlier today. I was prepping, and this array in the smallest format's only like $700 and some dollars.
Yep.
In US dollars. So you can get a pretty affordable system that could basically bolt on to an existing system or supplement what you've got going already. Pretty interesting. However, you guys are more than just the vacuum tubes and a tank. There's a lot of options on your website. Will you give us a little bit of a tour and talk about some of the other options out there, especially as we think about using solar thermal, hydro solar for HVAC systems?
Yeah. So one of the main benefits that we actually have, if you take a look on our website, you're going to be able to see that we have different options on the market. So we also have air-to-water heat pumps. We have geothermal heat pumps. All the pricing, all the technical data is on the website directly on it. Pricing, shipping, et cetera is there, technical specifications, manuals, user manuals, service manuals as well. Now, the benefit of using solar thermal is that you can combine it with existing systems or create a system. And that's what we find the beauty to be, is creating hybrid systems and taking the strengths of different systems and combining them to get a very energy efficient system, a very performing system at most likely a reduced cost compared to, let's say, comparing it to geothermal or other high-end systems on the market.
So give us an example of what that hybrid system might look like. And by the way, while he's scrolling off the website onto a couple slides here, these guys offer free design service. So if you're interested in kind of seeing what you could do with your house plans, they offer free design on that.
Yep. All you have to do is go on our website, click on design request, and there's a questionnaire. You can submit your forms. If you have any energy bills, you can have house plans that you can submit in as well. Kind of the goals, what technology you're looking for, and then we have somebody reach out to you relatively quickly with a proposal, kind of asking questions, what exactly you're looking for net zero housing, or you're looking for just energy, reduction or carbon footprint emissions, for instance, as well. What we have actually here on a small PowerPoint slide is a conventional system. So it's going to be an air to water with a hot water tank, so a buffer tank. We've seen this on the market, for a fair amount of years.
Let me have you pause for 1 second. You call it a conventional system. I don't think of typically exterior systems as being air to water, so this is a little unique in the marketplace.
Yeah, but it's in a way, this, if you were to replace the water component with, let's say, an air handler, it would still remain on the conventional side.
Right.
The difference is that on the buffer tank here, we have the heat exchangers. So if you were to take a conventional air source system that is air to air, you'd be able to actually place in like another coil inside and preheat the coming air into your furnace. So let's say whatever room temperature you're at, let's say 60 Fahrenheit, you can preheat that air going all the way up to, let's say, in the 70s, and then your furnace will kick it up from 70 to 80 in order to heat that environment that you need.
Got it. So it's acting like a preheater. I'm sorry, keep going on your diagram there. This is pretty interesting.
So the solar thermal in a case like this can be easily attached to a system that's, let's say, air to water, air to air as a preheater, essentially. And that's where we find the beauty of it, is that you don't necessarily have to go with a lot of collectors. You can just go with a very reasonable amount of collectors. 2 to 4 is the standard kind of residential what we're looking for.
So 2 to 4 of this size collector that we've got in the background?
Yeah.
Which, just for context, is like, I don't know, 6 by 8-ish, something like that?
Give or take. It's 6 by 8 feet. Typically, the 4 is going to be closer towards a higher use application where you have like a swimming pool, something like that.
Oh, I didn't think about that. Yeah, you could absolutely use this system to heat your pool, especially in a cold climate where it's a very short season without heating your pool.
Yep. And in the summertime, when you have an excess amount of energy, you can dump it into a pool. You can dump it into a greenhouse or any other sort of application like domestic hot water production, car wash, you know, a hair salon.
Heck yeah.
And in the wintertime, it's assisting your existing system, whether it's going to be air source or it's going to be water source as well. Another PowerPoint slide that I have here is kind of talking about it. We have an air to water system again. We're not necessarily yet preheating with solar or anything, but you can see that we can take one of the tanks, the energy stored in a tank, and then dump it into a pool. So where does this come into play is when you start doing conventional systems. Oh, sorry, I'm going the wrong way. When you start going the other way, you can start doing systems like this where you start to have solar collectors and they're going into an air to water or water to water system. And now you're taking that energy and you're dumping it into a swimming pool, you're dumping it into domestic hot water production, etc. So think about it as a preheat. Don't think about it as a main source of heating.
So one thing that I want to point out is that your outdoor units, these air to water units, they really look like a traditional, like, you know, I've got some Mitsubishi heat pumps at my house that are basically have a Freon line connected to my indoor unit. This unit instead is heating that water or cooling that water, right? They could be in heat mode or cool mode.
Yep.
And I lost my train of thought. I forgot where I was going with that. Oh, I know what I was going to say. But what's interesting and unique about yours is that they're actually very efficient, even down to below 32 degrees Fahrenheit, since we're in the States, or below 0 Celsius, right?
Yep.
And how much below 0 or below 32 Fahrenheit can you actually go with yours?
So with our current generation model, we can go down to minus 25 Celsius, which is minus 15 Fahrenheit.
Dang.
We'll be able to go to minus 30 with the new upcoming model that's coming out in about a month from now.
Holy cow.
The main efficiency difference actually comes in the variable speed because we're using the tank as a clutch or a transmission. So the heat pump can generate some energy when it's, let's say, available, when it's hotter outside. We store that energy in a tank. The solar is also preheating that tank. And then your floor or your air handlers using that energy without necessarily having to turn on your outdoor unit.
That's fascinating. So in other words, you really could kind of combine 2 or 3 different heating or cooling elements together. Your panels on the outside, your air to water heat pump, and a traditional, let's say, gas-fired, propane-fired boiler inside. All 3 of those are going to work together, and I suspect this chart is going to show us where the energy flows between those. Is that what you're pulling up next on that?
Yeah, so the other thing I wanted to say is that we have a geothermal unit that can actually recover some energy.
Well.
Yep.
Dang.
And the cool portion about it is that you can generate cold while it's generating heat, pretty much. And you can now heat a swimming pool while you're air conditioning a space. So when you start looking at the possibilities of combining, let's say, geo with air to water with solar thermal, now you can see that you can actually, instead of generating energy, you can just recover it from elsewhere, transfer it, and then whenever you don't have enough to transfer, then you can start generating it with solar thermal or balancing the system this way.
Fascinating. As a side note, these guys are not installers. They'll help you design, They'll sell you all the equipment, but you're going to need to either be a DIYer, which there certainly are a lot of people I suspect that do that,
Yep.
or you're going to have to find a local contractor to integrate everything and install everything, just as a point of clarification.
Yeah, we offer training to any contractor that's looking for training. If a homeowner does purchase the system and selects a contractor to do it, we'll give them the training that they need. We'll walk them through the system entirely. We'll also triple check everything and make sure that all the pictures look good, all the commissioning was done correctly, everything's fine, and we'll help them commission their first systems as well.
That's great. Very cool.
Yep.
So what are we going to show us on this slide then?
So on this slide, this is going to be a system that we're seeing here. It's going to be a solar collector array. It's going into a buffer tank, and that buffer tank is now being used to heat an environment, and it's also being used to heat a pool. So what you can see from this is that you can say, hey, if we're sizing a system for you, we can actually size it in such a way that you don't actually have excess energy, which is the problem typically that we see with solar thermal, is that at one point, if you go too big in the summertime, you have too much. So what do you do with that? And we also have solutions based on that, which is going to be seasonal thermal storage.
Seasonal thermal storage. What is that?
So it's a very cool thing that pretty much came from Europe as a technology. We expanded it to be a little bit more North American friendly. So we do something called high volume, low temperature seasonal thermal storage.
Huh.
And we will store energy beneath a house, beneath a home, beneath a garage, shed, whatever you're looking to condition. And that energy can be generated during the summertime when the generation is cheap. So for instance, it could be done with solar thermal. It could be done even with an air to water system that has a much higher COP for hot water generation in the summertime than in winter. And then you can actually withdraw that energy in the wintertime.
Whoa, that's crazy. So in other words, you're using a ground loop to act as a big battery.
Yep.
And so there's not a loss though, because if the ground's at, let's say, 50 degrees, there's not a giant loss from that heated water to the ground?
So the main benefit of going with the high volume, low temperature is that the delta difference between the ground and the surrounding ground is not going to be crazy.
Okay.
We're trying to heat the ground maybe up to, let's say, 100 Fahrenheit, 100 something Fahrenheit. The ground next to it is going to be in the 50s. Yes, there is a delta, but if you insulate that ground, which is beneath a house, which is already insulated, you're not really losing all that much. If you're losing any of it, it's pretty much going into your conditioned space now.
Yeah.
And that's the majority of benefit of building on top of seasonal thermal storage.
Wow, that's wild. So in other words, this could be the building pad before you even get going on construction.
Yep.
It will eventually be the battery that you're going to use.
Exactly. And this allows you to store more energy instead of kind of purchasing hot water tanks and having a lot of hot water tanks eat up valuable floor space.
Yeah.
You can have it all below ground, all below grade. And essentially that system is going to be maintenance free. You're not going to need to do anything to it. It's going to store a lot more energy than a conventional hot water tank, at whatever temperature you're looking to store it at. And you can actually withdraw that energy seasonally or months, years, down the line. And all that space that's heated pretty much is going to maintain its thermal mass. It's using thermal mass as a...
That's fascinating. I'm thinking of two houses in particular that I toured maybe 2 years ago. I was in a house in Vail, Colorado that had an indoor pool and had a whole driveway melt system and a giant amount of boiler capacity. I want to say they had like 1 million BTU boiler capacity to try and send enough hot to all those places it needed. I think this is a really interesting alternative, utilizing, basically the black garden hose when I was a kid method, right? Let's collect something that's free and let's use it in a smart way. That's fascinating. I mean, this technology's been around a while. This isn't new tech, right? We haven't just stumbled upon this a year or two ago. I didn't pre-plan this, but I'm going to put you on the spot a little bit. What is it about this that we're not doing this on every house that's new in Canada or every house that's new in North America?
So, arguably put, solar thermal was on the market since the 80s. It had a massive peak in the 2000s. A lot of the subsidies, governmental subsidies, died out at that point, and they started kind of pulling off the market. A lot of companies went bankrupt. What we did different and our approach, how it's different, is that we don't oversize systems, which was the first mistake that a lot of other companies were doing. They were generating so much heat that they didn't know what to do with it in the summertime.
Right.
And that's the first issue, is that when you oversize a system, you end up overpaying for it, and then you end up having too much hot water.
Right.
And now you're trying to figure out what to do with it.
Sure.
And a solution like this, which is seasonal thermal storage, for instance, is an answer to that problem. So why are we not seeing it? It's pretty much lack of information. It's not a very popular system to begin with. Every time somebody talks about solar, they think photovoltaics or
Right,
PV.
I think electric,
You know,
PV panels.
Everybody thinks about PV all the time.
Yeah.
You know, they don't consider solar thermal, and the reason why, because the energy storage was hard to do.
Yeah.
And PV is the same thing. It's if you're trying to store energy in batteries, batteries are also very expensive.
Yeah, batteries are not inexpensive when you think about those PV panels and trying to figure out a way to keep that energy on site. That's probably the most expensive part of PV, frankly, is thinking about those battery storage. That's fascinating. I think it's interesting. I think it's interesting how you guys have really taken a hybrid approach with multiple systems, multiple technologies to come up with solutions that would really work for a lot of houses and would take us away from lighting a match underneath your tank for the heat, right? Which is basically what a standard gas tank is.
Mm-hmm.
Fascinating.
It's the benefit of going with hybrid is that you're going to be able to mix and match products based on exactly what you need to do.
Yeah.
And that's one of the beauties of hydro solar, is that because we have a variety of access to different equipment on the market, we can pretty much size anything based on different manufacturers. We initially stem from an engineering and a consulting firm.
Yep.
So we used to do it for other companies, and we kept that approach even today, that if you come to us and it's not a product that we have, but you're looking for it, we're going to guide you in the right direction.
Yeah.
You know, we believe in designing systems that are right for the client based on the needs that they want and based on the budgets that they want.
That's good. As a side note, by the way, if you're watching this live, if you've got questions as we're talking, drop that on the Q&A tab. If you're looking on Zoom, it's typically on the upper right. It says Q&A. Hit that. We're not monitoring chat. If you put it in chat, it's going to get into the black hole. So go to the Q&A tab if you've got questions. Ian, talk to me about reasonable goals for energy savings with some of your systems. Like, is it reasonable to expect that we could get 20, 30, 40% savings on energy with a system like this, or even more?
Yeah, definitely. So what we consider to be reasonable goals are going to be based on your return on your investment. Primarily, depending on what state you're in, what province you're in, it's going to be the primary driver is going to be the energy cost. Mm-hmm. So reasonable changes and varies based on different provinces and locations. So a reasonable system for a solar thermal system would be 20, 30, 40% of your annual heating load and domestic hot water consumption. Okay. Potentially 100% of your domestic hot water consumption if it is tied to that. If you're going with seasonal thermal storage, you can exceed those numbers fairly easily as well. Right? Wow. So you can go 50, 60, 70% as well. Dang. Of your annual heating load. For sure, it kind of goes hand in hand with the envelope as well, right? Yeah, if you go passive home or you go net zero housing, much easier to reach those goals with a fewer number of collectors than it is that if you have a barn that's not insulated to heat, right?
I suspect a lot of people, Ian, that are using your systems are also putting some amount of photovoltaics on as well to get kind of the best of both worlds and take advantage of both of those technologies to make a house be the most efficient, at least tied to the grid as possible. Is that something you're seeing out there? Yeah,
we're seeing a lot of mixed systems when roof square footage or floor square footage is available. Mm-hmm. We actually even have a product called PVT panels. So PVT panels are actually a photovoltaic panel and a thermal flat plate heat collector.
So the T is thermal, PVT Correct. Panel.
Exactly.
Interesting. So how does that work? I'm sorry, I cut you off.
So that works, it's a PV panel, the conventional 350 watt panel, with a thermal collector kind of glued to it. It's a flat plate, so like a heat sink. Think about it like a big radiator.
Yeah, because they get hot.
Yep.
And the hotter they get, the less efficient they are too, right?
Yep. So you boost the efficiency of the PV system while you're also recovering some of that energy, and you can use that energy into, let's say, domestic hot water use or something like that. If you're limited in square footage, that would probably be the best solution for you, since you're combining two panels in one. But if you're you have the roof square footage available. Sometimes based on cost and availability of parts and everything, it sometimes makes sense to split them up and have, you know, PV on, let's say, roof mount and then vacuum tube on a ground mount system or something like that.
Fascinating. That's a pretty interesting option. So you could do 2 and 1. Ian, I think you've got me queued up for a bit of a case study on a kind of residential standard project that you guys do. I wonder if you could walk us through that next.
Yeah, so that's going to be this slide over here. So this is a client that we looked over. They're looking at heating their space for them. What we do is they approached us, they said, listen, we have a swimming pool, we're heating the house as well. We want to reduce energy costs a little bit. What's something that we can offer? So we took it as a case study. We took a different amount of panels, different configurations of panels, and we figured out that probably 3 panels with 30 tubes each would be the most cost efficient for them. And when we proposed it to them, we actually came up with this graph. So we do solar simulations for all of our clients as well. They actually get an annual like input per month or per week if they wanted to, based on how many kilowatt hours the system produces versus how many kilowatt hours the system will consume, like let's say the heating, space heating, pool heating side. And this is where you end up getting graphs like this, for instance, where you're in blue, your production of solar is higher than your consumption, which is going to be in gray.
Gotcha. So in other words, the summer months, obviously it's hotter. We got more sunlight, more days or more hours, I should say, of sunlight. So we're boosting that blue in the summer, but we still get decent production in the winter, it looks like, based on that graph.
So based on the graph that we're seeing here, or based on the performance curve that we gave to that client, we said, listen, it's if you go over the 3 panels, we will need to start thinking about energy storage somehow. You know, can we store it in essentially what would be like a septic tank? You know, we dig out a septic tank in our backyard, we'd insulate it, we'd fill it up with water, or we'd fill it up with sand and put PEX piping inside, and then store that energy there. Or if the spaces are, you know, premium and we can't do that, then we're saying, well, we're going to limit you down to like 3 panels because anything above that is going to just over-generate energy in the summer months. So it's becoming an assist in the winter, but it's going to be their primary heating source and their pool heating source in the summertime. They don't actually need to pay anything.
So all their domestic hot's taken care of, heat the pool through the winter time. And this is probably a northern climate house, I'm assuming. So is the gray bars on that graph the energy use in total, or what are we seeing there? I'm sorry.
Yeah, so the gray bar is going to be the heat load, so how many BTUs or how many kilowatts we're consuming.
Okay, gotcha.
Versus the blue is how much we're producing at the same time.
Okay.
So we're looking at producing anywhere from like 10 to 30% in the wintertime is our optimal goal, while in the summertime, in the summer months, we're reaching that 100%.
That's interesting. Have you ever heard of another type of thermal storage that instead of being hot is actually cold, like ice storage and some of that kind of thing? Have you guys ever walked me through what that looks like?
So we actually have a couple clients who are on the southern climate where it's cooling dominant. So what we do is we take our geothermal unit, which is going to look something like this. We're producing hot water and chilled water. We produce chilled water down to about 25 Fahrenheit, so very cold glycol. And that hot water that we now have access to, if we don't have a use for it, we can actually dissipate it with the PVT panels. So we just run the water through it, and assumingly that it's colder outside or that there's no sunlight outside, you can actually dissipate some of that heat as well.
Oh, interesting. So it could be dissipated at night, let's say, when those panels are cooler.
Yeah. And if you're doing it at night, you're essentially helping your chiller or whatever the case is produce that chilled water for the next day.
Right.
So clients that have, let's say, on-peak and off-peak energy bills, they might benefit from having a technology like this. And this is where the tanks come in play, right? It's your tanks give you a number of time that you can store, whether it's going to be cold water or hot water. And depending on the number of tanks you go for or the capacity of the tanks, you'd actually be able to offset the on-peak versus off-peak times.
Fascinating. That's pretty wild. Ian, one of our bullet points that we told people we'd get into on this is kind of best practices for the installation. I'm curious if you could get into a little bit of that install, what that looks like, what are the best practices, what do we need to know ahead of time, and maybe even like what do we need to think about before we even break ground on a project that we think we're going to use one of your systems on?
So the best approach that we found is that you reach out to us in the design phase or before you actually start breaking ground on any project. We take a look at the overall project, we take a look at what technology is applicable, and depending on the budgets of the client as well, we can see what is going to be the best outcome, the best result versus the goals that we're looking for. The good practices are definitely going to be, we do design requests. So once we submit a design request, you submit a design request to us, we give you an answer back. We tell you what type of panels, how many panels, we provide all the equipment that you need for it. We provide all the training that the clients need or the contractors need in order to service the equipment, to install the equipment. And essentially from that, we do follow-ups. So we follow up with our clients and say, hey, like, you know, you've had a system that you've commissioned like last year. Have you considered, you know, doing a inspection on it or something like that? And some of our clients have data loggers as well, so it's very easy to monitor the performance that they're getting. Some of them are, you know, simplified systems where cost is obviously an important factor, where we sometimes skimp out on some of the technological, like automation, and some of the work has to be done manually.
Fascinating. That's pretty neat. Do you guys have a list of contractors that are used to working with your systems? How do people get connected with folks who can actually do the install on these? Because ultimately you could buy pretty much everything you need except for the smart person to install it.
Yeah.
All right.
So
through you guys,
we have a list of contractors by area or by region available to us. It's not currently on the website, but we are working on kind of tagging that along sooner than later.
So people could actually contact you about that, though.
Exactly. But if they contact us directly, we can say, hey, like we've had this contractor locally install 2 or 3 of these systems that you're looking for. The challenge is that because we do such a broad variety of products, so whether it's going to be solar thermal, air to water, geothermal systems, that it's very rare to find one contractor that does all 3.
Yeah.
Right. And this is why we kind of pick the contractor based on the project.
Yeah. That's interesting. What have I missed on the slides and the presentations that we talked about ahead of time? Did I not cue you on anything? I'm curious if there's anything we missed on there that you wanted to get into before we jump into Q&A.
Yeah, so maybe just we'll follow back up on the geothermal heat recovery system.
Yeah, let's talk through that.
Yeah.
I'd like to know more about that.
So our geothermal unit on the ground loop side has a titanium heat exchanger. So you can provide cooling to an environment while also generating heat, which can be when going into a pool, for instance, directly. And one of the other benefits of, let's say, going with a geothermal system like this is that you can get a geothermal heat pump compressor. You can generate your heat and your cold at the same time, and then you can tie in an air to water system that is going to balance those 2 tanks out. Now, the benefit of this is that let's say you have a server room somewhere, or you have an environment that's always hot, a greenhouse, for instance, you know, that you're trying to extract some of that heat.
Okay.
And now you can take that heat and then dump it into your domestic hot water use. So based on the BTU output, based on the BTU consumption that you're looking to target, it can either be on a residential scale or all the way going up to like kind of hair salon, going to a car wash or something along those lines.
That's interesting. I wonder if there's applications there in multifamily too for you guys. I mean, you think about a multifamily building that's got, you know, 50 or maybe 100 units in one building. I would think that you guys would be a terrific solution compared to that million plus BTU boiler in the basement.
For sure, and this is where we also have offerings on the commercial side for heat pumps. What we can actually do is we can take one large chiller, essentially, so an air to water heat pump is a chiller, and we can generate hot water and cold water. We can store that in tanks, and then each individual unit can now draw whichever energy that they need via an air handler. So they can have an air handler like a wall mount unit. It could be a high wall, a low wall unit. It could be an integrated cassette or just like an air handler, like a central system, depending on kind of the multi-family residential that we're targeting here.
How efficient are those air to water heat pumps that you guys have out there?
So
what's the COP look like on those?
Yeah, so annually COP in Canada is going to be around the 2.5 mark that we're targeting for air to water. If you put it into perspective a little bit, centralized systems, let's say air to air that are going to be on the lower efficiency side, have an annual CFP of like 1.5, 1.3, mainly in the northern climates where we're using the backup heat a lot.
Yep.
Let's say mini splits are going to be closer to the 2s, 1.7, 1.8, 1.9. Geothermal annually is going to be around that 3.5, 3.7. It's rare to break 4.0 unless you're going with, kind of like an open loop configuration.
Yeah, 4.0 is pretty unusual to see that. Which, gosh, I wonder if could you break down the what COP stands for, or kind of what that means? It's basically, I always say the layman's version of it is, for every dollar I put into my system, how much heat am I getting out of that? And if I've got an electric resistance tank, for every dollar I put in, I'm getting $1 out. But in this case, we put $1 in, we're getting $2.50 out.
Yep.
Is that a good way to explain it?
Correct.
Coefficient
So
of performance.
it's going to be either in kilowatts or in dollars. Most clients understand the dollar approach way better.
Yeah.
Geothermal, there's an obvious cost of the well life as well that's usually not factored in. So the drilling cost of the well, there's, yes, the machine is very efficient, but the actual well itself has to remain efficient throughout its lifetime. A lot of the time what happens is if you're extracting too much heat on a system where the wells are undersized, that ground around the well is actually going to start becoming colder over time. And over time, you start losing COP, so it's called disturbed ground temperatures.
Oh, interesting. I don't know about that. Fascinating. It does make me interested, though, like what happens to these, like what's the general life of this panel that we're seeing on the wall behind us? How long would this panel last?
So theoretically, a panel like this is designed to have like around a 20-year lifespan.
Okay.
Typically what happens is you're going to have physical damage, hail, bird strikes, or, like I guess a branch falling on it or something. 1, 2 tubes could get knocked out fairly simply and, easily.
But if a tube gets knocked out, it's empty, right? Like it doesn't necessarily mean that we got a leak or we got a problem with the system. It's just going to reduce our efficiency. Is that true?
Exactly. So we're just losing a little bit of heat, and then all it takes is just unscrewing the cap on the bottom and then just pulling a tube out, replacing it, kind of like a light bulb.
Is that right? Could you actually do that for us? I know we got a stool in the way we got to move it. That'd be kind of cool to see. Will you unscrew one and show us how that works? I'm a little impromptu here. I didn't tell my team that we were going to do this. Sorry, guys. Let's see this here. Do one right in the center that we can catch it on this center camera right here.
So all you do is at the bottom you have a plastic cup, essentially what we would call.
Yep.
And you would unscrew it. It's also replaceable.
Okay, so this is just it looks like a PVC kind of cup, and it's got a I don't know, 1/2 inch or so. Probably it's in millimeters, not inches.
And then all you have to do is you have to like twist the tube down.
You got the wrong one. You're one over.
Oh. Is this one? No.
Yes, that one.
Oh, it's
there you
this
go. So then you're twisting. Oh, there you go.
There you
that's
go.
it.
And once you take it off, all you have in here, so you have the vacuum tube section.
So if we broke one, if a bird hit one, if hail damage happened,
Yep.
it looks like it's pretty doable to change this.
Yeah, it's pretty straightforward. You can actually get them as an assembly. So you can
really?
get the whole thing actually built in as it is right here from factory. Or you can actually get individual parts as well.
Really?
So you can get just the glass part if the copper rod is still good.
That's kind of cool.
We recommend usually kind of taking a look and replacing the whole assembly if it's closer to the 15-year mark if it got damaged. Because the copper tubes itself, they have corrosion that may happen over time.
And is this filled with something inside here?
Yeah, so this is filled with essentially like a refrigerant. So it's a liquid, and when the solar, I guess, energy kind of hits it, what you end up having is a greenhouse effect. The vacuum keeps the heat inside.
Okay.
The selective coating absorbs this heat. That heat is now being transferred with this heat exchanger, so it's like a aluminum little paper.
Oh, interesting.
Heats this copper rod. That glycol makes, essentially, it's like an ethylene that boils over, becomes a vapor. Goes to the top, so as long as these collectors are manifold upwards, they will start generating energy.
They need to be pitched somewhat, basically.
Yes.
And how hot is this getting up here at that gutter?
The bulb can actually go up to like 500 Fahrenheit on a
What?
theoretical. Yeah,
Holy cow, that's hot.
Theoretical maximum on the gutter system itself, as you call it, the manifold, we're looking at 300 Fahrenheit maximum. Typically, since you want to keep costs down on pumps and let's say fittings and O-rings and whatnot, you're probably going to want to run like below 200 Fahrenheit, so below boiling point.
And my guess is the faster the glycol runs through there, the less heat it's going to catch. Whereas if it lazily goes through there, slower pumping, then it's catching more heat. So that's probably going to change your temperature. Am I accurate in that guess?
Yep, that would be correct. So depending on the type of, I'll throw it on later.
Yep, sounds good.
Essentially the flow rate that you're looking to get and the delta rise that you're looking to get is fully adjustable. So we have some clients that are looking for high flow applications with a small delta rise. Sometimes we're looking at a low flow application with a higher delta rise.
Interesting. That's fascinating.
Yeah, it really depends if you're going into a heat exchanger, into a buffer tank, if you're going into a pool application or whatnot. There are favoritisms of going with different flow rates, right? It depends on the pipe diameter as well.
And you guys are doing the engineering to say, hey, this system with these 2 panels or 5 panels or whatever would match well with this size tank based on your climate zone, your orientation. You're probably even using Google Maps to try and figure out location, that sort of thing. Am I correct on that?
Yeah, so we use Google Maps, and then on our solar simulator, it's a software that we have. We can actually pinpoint the location, pinpoint essentially the angle of the panels, what angle they're going to be, and based on a historic data of that city, how many hours of sunlight they've had, let's say in the wintertime, summertime, etc., we can actually predict data going forward as well, and the performance of these panels.
Have I seen in years past that there's a version of this that's like a flat plate type version? Is that other manufacturers, or is there a difference in the efficiency or a reason why you guys use this tech versus other techs out there?
So flat plate is going to provide more energy in the summertime, but way less energy in the wintertime.
Oh, interesting.
And the reason for that, it's like a radiator. So think about trying to recover some heat from the sun while you have a radiator that's exposed to cold. Versus with this, the only part of the glycol that's exposed to cold is going to be in that collector that is insulated, and then the piping that is normally also insulated. So you're generating heat from a large area, and you're condensing it to one location. As opposed to a flat plate as a big radiator.
Right, because these tubes are like 6 foot tall, something like that. And so you're collecting 6 feet of that tube, and the tube is able to get the sun's best angle no matter where the sun hits it. And that coating you mentioned was selective. What did you remind me what that means?
Yeah, so the selective spectrum coating that is applied to the tubes is a specialized coating that essentially just absorbs a specific wavelength of sunlight. And we're looking at absorbing infrared, which is what we feel when we go outside, right? The infrared heaters, if you've ever had experience with those. You walk into a shop, you see a light bulb that, is glowing red. You walk past it, your face is blazing, but the rest of the room is actually pretty cold.
Right.
So it's the same concept as that.
Got it. So it's grabbing that infrared heat. And I didn't realize that there was almost a refrigerant inside those copper tubes as well. What did you call that again?
Yeah, so that refrigerant that's inside is going to be, it's a glycol-based system, so it's an ethylene glycol-based system. It's contained in that copper rod, and the general use of it is that we're using phase change. So we're going from liquid to gas, and that's what's allowing the temperature to go up significantly higher and faster.
Gotcha.
It's heating water versus heating gas. Heating gas is a lot easier and faster.
That's really cool. Fun. Let's switch gears to some Q&A if that's all right, because we're down to about 15 minutes left in our time. We told these guys we'd not take more than an hour of their time. By the way, if you've got a question and you're live, go ahead and throw it on here. More than one Philip has posed some questions that I think are pretty interesting. Let me start with this one. Philip Valenta says, Matt, have you considered air to water for a home? Also, have you ever looked into low temperature hydronics for any of your other builds? And then he mentioned someone specifically has been championing this for decades now and lives in upstate New York. Interesting enough, we just did a build show build Boston house with a gosh, I'm totally blanking on the rating.
Warm board?
Warm board, thank you. Sorry, warm board friends. With a warm board system. And Warmboard now has come out with their own version of an air-to-water heat pump, which is, I think, by Space Pack. And so Warmboard is now doing kind of a all-in-one package system to say, hey, we can either get your heat for your Warmboard floor heating system from a Space Pack outdoor unit with a very high COP, or we can do it from a traditional boiler with either propane or natural gas. So I'm hearing more and more about air to water. I feel like this is a hot button topic that I could use a whole webinar on, but I also need to educate myself on a little bit more. The thing specifically that's so fascinating about your system is we can do both radiant heating and radiant cooling potentially in a house. Talk to me about how your system could be used towards radiant cooling.
Yeah, so there's two different approaches to it. So if we go with air to water, we have the choice of having a single tank or a dual tank. If we have a single tank configuration, the heat pump switches into cooling mode, and so essentially it reverses. Once it's reversed and it's in cooling mode, we generate chilled water. That chilled water gets stored in our buffer tank, and then we start circulating that chilled water in our floors with something called a dew point reset sensor. So we either can do it mechanically or we can do it electronically, with essentially the water being sent out to the floor that is going to make the floor about 2 Fahrenheit colder than ambient room in order to prevent the floor from actually having condensation or dew point being formed on it.
Right. And so then you're going to take care of the sensible heat, you know, the heat that's in the air, but then we still need to deal with the latent heat, which is basically, you know, humidity, right? For lack of a better term, when there's humidity present, when there's water vapor in higher concentrations in the air, that feels like it's hot to us. And so by removing that with a dehumidifier, we can now space cool the house with a radiant system, no air blowing whatsoever, right? Or potentially, I guess there might be a little bit of air blowing with the dehumidifier.
Yeah, the generalized idea is to reduce the number of air that's being circulated, right? You want to still make up, like, you know, the fresh air system, the makeup air system as well. You just want to make sure that you're dehumidifying. That could be done with an HRV, ERV. It could also be done with a fan coil. So you could actually take a fan coil unit that now needs to be significantly smaller since a lot of the load is being taken care of by the floor.
Yeah, that's good. We got another question that came in, but I've got a side note to that. Did I see on your website that you guys are selling dehumidifiers as well?
So we do pool dehumidifiers.
Pool dehumidifiers,
Yeah.
okay.
So this is going to be for indoor pools. We have dehumidifiers that are specifically made for that. It's made by Nordic in Canada. So we distribute that product. We do all the design services for that product as well. And it's essentially when you have an indoor pool, you want to make sure that the humidity doesn't actually affect the structure or the building itself, and maintaining it at 50, 60 relative humidity.
It's funny, us Texans down here in the South have no idea about indoor pools. I can't even imagine even my richest client saying I want an indoor pool. And yet when I travel up north, it's like the thing. If you're going to build a mansion, you want an indoor pool. A natorium, am I saying that word right? I think is the name of that, which is an indoor pool. And I've seen them on houses in Boston. I've seen them on houses in Pennsylvania and lots of places. It's definitely a thing, and it's not for me in the South. So I would have no idea what to do in terms of all the mechanicals and all the things. It's interesting that you guys sell into that.
Yep.
Another question from Phil Newman here, which is a great one. What additional depth is needed if a seasonal heat sink is designed to be under a foundation? In other words, I think he's saying, like, is this like excavating 20 feet to get a seasonal heat sink, or can we go a foot or two down before we put our foundation in?
So that's going to depend on the square footage that we have to play with. If we're looking at, let's say, a big house that has a big like BTU heat loss, and we're looking at storing a lot of energy, and we only have the square footage of what it would be essentially underneath the garage, we'd have to layer it over multiple layers, each layer being about a foot. So it could be 5 or 6 feet, let's say, if it's only on the garage square footage. But if it's on the whole of the square footage of the home, so let's say it's a relatively large home, like 1,000, 2,000 square feet floor space, you're probably looking at a foot and a half typically, sometimes 2 feet depending on the energy.
Yeah.
The tighter the homes, the more energy efficient the homes are getting, the less you actually start to need of all of this.
Yeah, fascinating. What have I missed? What questions do you have that are the frequently asked ones that didn't get asked today that you'd like to bring up?
I guess the biggest kind of question that I guess a lot of clients ask us, like frequently asked questions, would be the buffer tank sizing as well.
Oh, that's a good
So,
question.
air to water heat pumps, as well as boilers, benefit from having a buffer tank. So the reason for that is that you can actually modulate your production of energy versus your consumption of energy. So you can have, for instance, a heat pump that's generating at X amount of BTU per hour. It's storing it in the buffer tank, and then from that buffer tank going to your radiant floor, well, that segment can also be hydraulically separated now, right? You can have two different flow rates, you can have two different delta rises, you can have anything that you want, and the buffer tank allows to do that. So can you get away with a small buffer tank? You could. Is it going to be the most efficient way possible? It will not be, because you're taking that heat pump and you're essentially taking it from a variable speed into like essentially what would be like a 3-stage or a 2-stage system. It now has to run at X amount of RPM in order to keep up with that demand.
Right.
So the larger the buffer tank, the larger the thermal mass, the more you start getting benefits of systems like these.
These are nice systems. If this is a full stainless tank, I would think that thing's got a long lifespan before it's going to give out.
Yeah, we estimate that the lifespan on tanks like this should be closer to 20, 25 years easily.
Yeah.
Based on jurisdictions, depending on how it is, it's sometimes if you're running open loop configurations or whatnot, it could be the actual contaminants of the water that are pretty much sedimenting on the inside now, as opposed to the actual tank corroding itself.
Yeah. Yeah. Fascinating. Ian, very impressive, man. Good stuff. Guys, if you are interested in learning more about this, Ian and his team are available for you. They have a great website, a very, very impressive website. It's right here. It's hydrosolar.ca. Don't be fooled by the CA website, though. They ship all over the place. It seems like they're even shipping really worldwide, not just North America wide. These systems make a lot of sense to me. I was trying to think of some kind of real life examples of why this makes so much sense. And my family and I do a lot of camping. And one of the things that I enjoy when I'm camping is making coffee at whatever campsite I'm at in the morning. And I've got a little camp stove, right, that I fire up with a little propane tank. And it always is interesting because my coffee maker at the campsite is quite a bit slower with that flame underneath it than at home when I've got my, let's say, my induction cooktop going and I'm boiling water on my induction cooktop. And so it's such a visual indicator, seeing that flame actually touching the bottom of my pour over little fancy coffee thing that I've got to pour over my coffee. And a system like this eliminates that flame and eliminates those BTUs. So no matter what side of the aisle you vote on, it really boils down to making a lot of sense for you as a consumer, for your personal house. Forget about even the energy savings. Think about the resiliency that this brings to you as a homeowner. You know, when the power goes out, you need much less generator to operate your house if you've got a system like this going. Add in a little PV to that, maybe even add some battery storage. Your entire house could be unplugged from the grid in a couple of years without any loss of comfort, efficiency, durability, any of that. I mean, that sun is so incredibly, it's such an incredible amount of energy hitting the earth every day. And this 8x6 panel is taking advantage of that to bring you some free heat for your house that can be used in all kinds of places. I mean, it just makes total sense. All we got to do is figure out the engineering behind that, put it all together, and take advantage of that. And you guys have put together a pretty amazing system for doing that, where you guys are manufacturing and selling direct to folks. So Ian, I really appreciate your time today.
Perfect. Thank you so much for having us here.
Any last thoughts or anybody that anything you need to direct people to at your company if they're interested in learning more?
Well, if they have any questions, they should always reach out to us. We're very open about even students having questions about net zero goals or net zero housing and et cetera.
Cool.
We haven't spoken much about it, but in general, it's anything that's educational based, we love to spend time with people and actually educate them as well on the systems. And even if it's not the right fit for them, then at least they came out smarter from the experience and they know that a system like this does exist.
And by the way, they have a great blog with a ton more information. So if you want to take a deep dive on their blog, that's a great place to learn more. Is there any email address that's an info ad or that kind of thing for you guys? I know I'm putting you on the spot here. Or what's the best place for people to reach out?
So best place is going to be design@hydrosolar.ca.
Okay.
So it's just design@hydrosolar.ca.
Gotcha.
Alternatively, you can just do a design request. And that's probably going to be the best and easiest way to reach out to us.
Yeah, and I saw on that too, you can upload plans. They've got a great questionnaire there for you, so you can kind of knock out a bunch of questions ahead of time. And Ian told me earlier they try to get back to you, depending on their lead flow. They get back to you in 2 to 3 days. So they'll get back to you, and some great people to answer your questions there. Ian, thanks for your time today, brother. Thanks for coming down to Texas to hang out with me in the Build Show studios.
Thank you guys so much for having us here, and we'll see you guys soon.
Appreciate it, guys. From the Rockwell Studios here in Austin, Texas, hit that subscribe button. You know, we've got new seminars, new webinars on a monthly basis. Oh, and lastly, I'd tell you, look for our email, or look for our, on our website. We've got a join our mailing list, because that's how you know about these live seminars, so that you can actually ask a live question and join us live. But of course, you can always find our past webinars on the website, thebuildshow.com. Guys, hit that subscribe button below. We've got new content every Tuesday and every Friday. Follow us on Facebook or Instagram. Otherwise, we'll see you next time on the Build Show webinar.